In this video, we're going to talk about Quarch's USB-C power analyzer fixture. So this is a fixture which can measure power on any USB-C device, of which there are many out there. And I think we're going to try some cables and devices, right?
We are, yes. Shall we hook it up first, just to show how simple it is to put together?
So I've looked on YouTube and I've seen many of these for £5. Why would I want this one?
Maybe not £5, but yeah, you can buy cheap power analyzers. I've tried them before. They will give you a basic instantaneous reading of what your device is doing, but it's not calibrated. It can be hard to take the data off it. In this case, we're able to capture at high resolutions up to 250,000 samples per second. We can capture for hours, and it's calibrated, and it has an automation suite behind it. So this is a commercial product. It's not a toy.
Great. Well, let's plug it in and see what happens.
Fine. You stick it into my phone because I could do with a charge. It's the analyzer. So we're going to use USB in this case. We could have used Ethernet as well.
So the power analysis system is a fixture which changes, and then a common module. So we've got the two parts here connected, which are then connected into a laptop. And now we need a power supply.
Right, so that's in the high power ports.
I can plug that in.
I'm going to start recording.
You ready for me?
Yeah, go. Just going to turn the channels off.
Okay, we are charging.
We are charging, yes. We are charging at around 5.5 watts at the moment. So not hugely impressive. We can see it jumped up in 2 steps. So there's obviously some negotiation between the phone and the charger. 5-6 watts. It's not very impressive from this supply.
So what do we expect to get from this power supply of this phone?
It will depend which of the ports we're plugged into. This is a USB-A port at the moment. I would hope to get at least 8 watts though. In the USB-C port, we should be able to get near 15.
Okay, should we try some more cables?
Try another cable, yeah. Unplug that one. Right, so here we got USB-C cable. So this can go straight into the power delivery port. I'll plug this one in.
And fast charging, super fast charging.
And we can immediately see the difference. The previous one, we were running at 5 volts continuously. Now we went briefly to 5 volts and then up to 9 volts. And actually the current, you see how the current is still slowly going up. So the phone and charger are negotiating constantly and incrementing the current, and we are now running at 21 watts. So hugely better.
Much faster.
Let's try another one.
Great.
I have my son's fancy green cable here. Let's see how this one does. This one has built-in lighting effects.
Oh, excellent.
Okay, we're back to 5 volts again this time. That's not surprising. There's not many chargers with USB-A that's going to negotiate to a higher voltage, although some of the Anchor ones can. I'm seeing no charging effect. Half a watt, if that. I don't think this cable is actually happy at all. So try unplugging and plugging it back in again. No, this cable I would say is dead. The voltage is getting to the phone. But it's not charging in practice. My guess would be that it is some of the sidebands are damaged. It did used to flash green at one point.
I saw a little flash a moment ago.
It's not anymore. So I think we can put this one in the dead box. And should we try a different power supply just out of interest? Sure. So here's a much smaller battery. So we can test multiple cables, but we can test a lot more than different cables. We can also test different chargers to see how the chargers run. So if we identify one good cable, then we can start testing the chargers. So 5 watts, 5 volts, sorry.
So can I use this product to measure the capacity of this battery?
You could, yes. So you could either, or in both directions, you could measure the power going into its charging port over the entire charge cycle, which could be, half an hour to a couple of hours to charge it. And then you could do the same in reverse. So you could both measure the capacity of the battery, draining it in practice, and also the efficiency of the round trip of the charge in and back out again. Yeah. Let's just try a short one. Now, this probably came from a headphone charger or something like that. These ones are not always fully wired. And if you don't have the data wires, then some of the communication between the device and the charger might not work, and it may not do anything. So it's working, but we're charging about 2.5 watts. So that's really poor. And the phone has probably identified that this cable and charger combination is not.
So I think 2.5 watts is the maximum for a USB port to provide when it doesn't have any communications.
Right. I mean, that would make sense. So it's on failover mode. So it will charge, but it's going to take a long.
We're on 5 hours now. That's a long time compared to the hour we saw before.
Not great. So another thing we could do with these, though, it's not in the scope of what we've got here, but if you took the battery out of the phone, you are then measuring the power consumption of the device directly. And at that point, we could open different applications and we can look at how having something like Google Maps open, for example, is going to affect the battery life on the phone. We could change the phone into low power mode and immediately see the change in power consumption. Now, with the battery in the way, we're not going to be able to see that because we're measuring the charging of the battery. But understanding what your phone is doing and different workloads is hugely useful for optimizing battery life in future. So there's a lot of things we could do with this. And of course, outside of just phones, USB-C is everywhere. We've seen uses in medical devices, in automotive, and beyond. So I think this is it's a neat product to get the data you want. And of course, we've been recording here for just a few minutes so far. All this data can be exported. The nice thing to do would be to annotate it. So each of these cables we plugged in, we can annotate the start and the end regions of the data, and then we can automatically calculate statistics between them. So this is a bit of a manual test, but in many cases, I would imagine people will want to automate with Python, capture as much of the data as possible, perhaps again, automating different workloads on the phone, and then come back and analyze that data later.
So if I was developing this phone and I wanted to do different power performance workloads, I can automate that process. I can have a script which kicks off a workload, annotates the file, gives me results.
Exactly. You could leave that running overnight. You could have 100 different workload cases. You come back in the morning and you can just order by your best and worst case. And you can instantly see where are the areas for improvement, where are the things that don't work well.
Great.
And of course, we can record a lot faster. We're recording 1,000 samples per second at the moment, but we can go up to 250,000 samples a second. So if you're more interested about inrush current or small detail or peaks and drops, exactly, we can zoom right in and capture that as well.